Okay, our project, like this is our main device. This is a scanner. What this will do is this will try to get all the registered BLE addresses from our web using MQTT. The web server will like transmit, publish those like known BLE addresses to a JSON array, and then this will try to get the JSON array into a C++ array, and then we'll store it in this device. And then we'll try to scan every available BLE addresses, and then we'll compare it with those known BLE devices. When it found the device, like it will try to access the RSSI, and then we'll try to get the proximity of those RSSI. If it's like near our, like, let's say like this is our tag, this is a known BLE devices, it's also registered, and then like, if it gets close enough, the LED will blink up, and then like if you have any other sound system or like any other indicator that like it will indicate like it found the known BLE device in registered BLE device in the proximity. And then after that we can start throwing the trash. Let's say like if the trash is the desirable trash, like a bottle or a can, like it will detect, and then it will send like a +1 to like corresponding to this tag to the web server, and we'll update it in the web server, and that's it. We propose to like do a minus point system for like unknown trash, other types of trash, but we try to do it, but it was not successful because the data that we trained were from like available data from the web, like it only has like bottles and cans, so it will detect every other thing as an available trash, like even humans. So it will work, unfortunately. So we just try to do it +1, and that's it. And also we propose to like have a point transfer system between students, but we don't have that much time, so we skip that. So I will show you a demo of the scanning part, and then maybe a demo of the detecting part. This is a demo for the scanning part. Like if it's known BLE address, like tag, it will show it by blinking. Like it said like it is in proximity. If it went farther away, it will say like it was not known, like it is not in proximity. So if you throw the trash in during that period, like it will not send you anything. Like it will just be null or white. We do. Can I have the view for object detection? Where is it? Yes. Yeah. Tracking. Detect, not detecting. Tracking. Where is it? Program. Oh, okay. Video. You did it with Jupyter Notebook, right? You showed me. Yes. Okay. This is the final videos. Like it will have become like we can go to the web and log in using student or like admin. If it's like known BLE device, it will link up, and then you can start throwing the trash. Like if it can detect, like it will automatically update the points. Like here, like we are throwing the cans and the bottles. Like if it can detect, like it will update the points automatically. For this project, like we use a computer because like the one that the Raspberry Pi that we have has only 2 GB of RAM. Like if we can have like Pi 4 with 8 GB, like I think we can implement this detection model to the Raspberry Pi as well. The communication between the detection and the MQTT ESP32 was done by just UART serial communication. Like if you can detect bottles or a can, it will send one to this ESP32, and then it will wait for that serial communication. Here are some codes that you may want to know. For the ESP32 main scanner, like first, like it will try to set up the Wi-Fi, If it cannot connect the Wi-Fi, it will just loop here like forever until it can connect. If it can connect, like it will go to the next reconnect. It is MQTT connect. It will try to connect to our desired broker with like our IDs and subscription topics and stuff. If it can detect like those, if it can did like successful like those things, like we can send using Python script or like this code can be implemented to the our server, and like it can send those like known VLE devices with like JSON to like every time those database is updated. Here's the result that like this can successfully scan, receive those published data, and then like it will show like what is in the arrays of those like unknown VLE addresses. Here, like this show like it can scan like every available known register devices, but only if that device is in the proximity. Like let's say like -20 RSSI, it will show like we will do the detection part, like, and then it will also print out like that register device is in proximity. Here, this is a code for like HTTP post. Like we try to post like update the points using HTTP post. At first I did it like for everything. Everything means like if the gain point is 0, like if the student is not throwing the, even if the student is not throwing the trash, like we will send the data. So like that is like too much information for the server. So I try to did it like if the gain point is not 0, only then like we will try to update the database, the points. Here I didn't make it like equal 1 because I also implemented in the code like what if it's like -1, so that we can implement like non trash, that unwanted trash data like later spawn in our object detection part. The HTTP, we will start by HTTP begin with our link, and then we will set up authorization. Maybe we can also add headers, and if that like we can post it, it will like get the response code. If we cannot, like it will print like request failed. I also implemented the MQTT publish for this site as well. If you want to use the MQTT subscribe, you can do that too instead of HTTP post. You can just receive those MQTT subscription using this snippet. You can just command it and implement it into your code. If it can like successfully post it, like this will be the response code. Like the servers will receive the HTTP post, but it said a session error with 201. But we successfully like can could update the code like the points. Here is the MQTT receive from the server side if you want to implement the MQTT. Can we have that detection? Oh. Okay, this is a video for object detection. Like if it can detect like there will be as ID. ID means like let's say like if the bottles or the can is already detected, we will set up an ID, and it will be there for like 30 seconds to like 1 minute, so that student cannot fake the drawing, like getting in and out of that camera frame. So that we put the ID to every detected bottles and cans, and then, so that they will not hack the system, something like that. So that is all for our projects. Like if you have any questions.
Kun Sukanya, do you want to ask anything?
Not yet.
Go to just look. Kun Sukanya, do you want to add anything? Or Dr. Kisda? not yet.
I do not have any question yet, Professor Supachai. Thank you.
Okay, thank you. What about this is about the image classification, right? Problem. What about the accuracy that you earn right now?
Actually, object detection was not done by me. 80%. It was done by we do. Can you come and explain anything?
For the accuracy of our system, we achieve 84%.
84%.
Yes.
How many class?
We use only two classes, which is the portal and
One.
for this we did not train our computer. We find the available data on the internet, but the shape of the portal and can that we find online is a bit different from the portal that we pay. Because like in Thailand, the portal and the shape is quite a lot different. That's why we did not achieve a good accuracy.
Okay, very good. Okay, so what about the range detection? Is it accurate? Who do it?
Yes, range detection for ESP32. Right?
Yes.
Yes, I did it for the past. Actually, like we can change the threshold to anything that you want. Like you said, like if it's in the very noisy environment, we can increase the RSSI threshold to like, let's say not decrease to like minus 60 to like minus 70 up to minus 100 and you want. But like if it's in the
ย่างปลาครับ
less noisy environment, we can reduce it down to like minus 20. So like it is in a very tight close range proximity. So we can do it.
Okay, thank you. Okay, any of you would like to have any question with this group? It's a child. It's a child now. Did you have any class with them?
How many prototypes can you? How many prototypes can you specify? Actually, like even this image classification models work for like the bottles that we didn't even train. Like it worked on the bottles that we didn't even train. Like yesterday night, like we try using the food cans from Burmese, Myanmar. Even then, like it can detect, like successfully detect, like they are the can. In fact, like we did this model did not even see like not a chance of those. Like even in like the colors, like the text, everything's completely different, totally different. But even then, like it can detect like those are in fact the cans, something like that.
What is the model that you use? I mean the architecture that you use.
For the architecture, we combine two architecture. The first one is object detection. We use the YOLO V4.
Okay.
Even though that there's like YOLO V8, but we try to implement it on the low computation device. So we decide to use the YOLO V4 timing, which has the 24 layer.
Okay.
And we use the darknet framework to train it. And after it, we use the deep shot algorithm for tracking, because like object detection, it detects object in its range. So if we try to count it with using the bounding box that we show, it will be count in each frame. So it is not what we want. So we use a tracking algorithm. So the tracking algorithm, DeepShot, it uses the current filter to predict the movement of the bottle and can, and we apply the ID on each object. So when we count, we record the ID so that it won't confuse.
Okay, that is very good.